So hi everyone, I'm Kristen Happ. I have been working for Stacklet for a little over 3 years now, and most recently I've been working as a technical customer success manager. This basically means that I provide technical assistance to our customers, which a lot of times is heavily Cloud Custodian focused since we sit on top of Cloud Custodian, and then also just ensure customers are getting value from the Stacklet product. And then prior to working for Stacklet, I worked for a large financial services organization. And when I worked there, I helped manage large scale cloud custodian deployments across the enterprise. So over the years, I've had a lot of experience authoring cloud custodian policies. And now that I'm at Stacklet, it's really nice because I enjoy finding opportunities that other organizations can implement within their workflows as well. And it's just one thing that I've really noticed over the years is that more and more organizations are looking for ways to save money within the cloud, and that's usually one of the first topics that people raise when they're looking into Stacklet and Cloud Custodian lately. And sometimes just finding one opportunity to focus on can save tens of thousands of dollars, if not more. So what I'm hoping is that this presentation can help generate some ideas for other organizations to save money as well. Fun fact, I had to think about this one for a little while. Um, my fun fact is that I have two kids. I have a 5-year-old daughter and an 8-year-old son who pretty much consume my entire life. And like probably too many other kids these days, they both watch probably way too much YouTube. So this morning when I was getting them ready for school, I let them know that I had a presentation today and that it would most likely be posted on YouTube afterwards. And so it was kind of adorable because both of my kids this morning, they thought I was famous. So thank you, Umair. I, I think you're making me famous in my household. So to get started, um, so the concept of the presentation is that every cloud bill hides a treasure if you know where to look. So most teams start digging into compute and storage, but the real hidden treasure often lies deeper, which is in the network optimizations and the GPUs. So that's where some of the biggest, most overlooked savings can be found. So in this presentation, we're going to look at a few ways to uncover some of these savings. So today, when we think about cloud cost optimization, everyone almost always thinks of compute and storage resources, but the reality is that idle or misconfigured network resources, which are things like elastic IP addresses, NAT gateways, and load balancers, they continuously keep charging your account and they're not as likely to be noticed. Additionally, data transfer costs across regions or out to the internet can spiral out of control very quickly. So the real challenge is that these costs are rarely visible in standard optimization dashboards or reports, which means that your teams are going to lack the visibility and the ability to take action in a timely fashion. So that's why these drains are often staying hidden and then they keep adding up month after month, year after year, and beyond. So we're going to talk about what's really driving these hidden costs. So a lot of times the first suspects are things like unattached elastic IP addresses. These continue to incur monthly charges even when they're not in use. And then next we have idle NAT gateways. These charge both by the hour and then per gigabyte of traffic. And so when you're looking at a NAT gateway that's just sitting there, it seems pretty harmless, but it's still costing you money every hour that it's left running. Another example is for idle load balancers. These remain active and billable even when no meaningful traffic is flowing through them. And then the last example is for cross-region replication and backups. And so these are often set up for good reasons, for resilience or compliance, but they also create significant ongoing data transfer costs, which many teams don't monitor very closely. So just to take a look at some of the examples that I was just talking about in the previous slide, this just shows a policy that looks for idle NAT gateways. And this policy has quite a few filters that detect NAT gateways with negligible data transfer and connections over the last 7 days. What's great about Cloud Custodian is that you can customize each policy to look at the metrics that meet your organization's needs. So you can take this policy example and then you can adjust it to whatever your organization would need to look at. And then another common variation of this policy that I've seen in the past is to look at active connection, just look at the active connection counts without looking at the metrics as well. So that can be adjusted as well. And this sample shows an action of sending a notification, but I did check and it looks like Custodian also has the ability to delete these unused NAT gateways as well. So you can completely automate this cleanup. And then another example that I had mentioned previously is just cleaning up elastic IP addresses. This one's pretty basic. It just looks at the association ID, and if it doesn't have an association ID, it releases them so that you're no longer billed. So that covers what what organizations most commonly look at when they're looking for cost savings. The new topic that we're going to cover today is when we think about hidden costs in the cloud, GPUs are quickly becoming one of the biggest culprits. And unlike compute or storage, GPUs are extremely expensive. For comparison, a standard compute instance might cost a few cents an hour, but a high-end GPU instance like an AWS P4D with A100s that runs at over $30 an hour. So if you add all that up, that's more than $20,000 a month if it's left running continuously, whether it's actually being used or not. And that's where the problem comes in because once a team spins them up, they often stay running even after the workloads are finished. And these orphaned or unused GPU instances quietly rack up massive bills. Another challenge is visibility. So most teams aren't actively monitoring GPU utilization or VRAM usage. So even when a GPU is technically in use, it may be sitting idle 90% of the time. So if that happens, it could be burning thousands of dollars with little to no value. And finally, the wrong tier choice is a classic mistake as well. So for example, if you're using a top tier H100 instance at $40 plus an hour, when the workload could run on a mid-tier GPU at $5 to $10 an hour, that mismatch means that organizations are paying 4 to 8 times more than necessary. So now that we've seen how GPUs can become a hidden drain, we're going to look at the 4 most common pitfalls that drive costs out of control. So first, idle or low utilization GPUs. These are instances that stay running but spend most of their time at under 10% utilization. Even at that level, a $30 to $40 per hour GPU racks up thousands of dollars each month. Second, oversized GPUs. So it's common to see A100s or even H100s, the most powerful and the most expensive GPUs, assigned to jobs that could easily run on far smaller, cheaper GPUs. So just to put that in perspective, the mismatch is like renting a stadium for a 10-person meeting. And then third, we have the zombie workloads. These are GPUs that are technically attached to a VM but aren't running any meaningful jobs. They just sit idle and consume budget. And finally, unrestricted provisioning. Without guardrails, anyone in the organization can spin up a top tier GPU instance with a few clicks. Sometimes this can be for experimentation, sometimes by mistake, and those costs pile up instantly. So together, these 4 patterns represent the largest share of GPU waste we see in real life cloud bills. So now that we've talked about the GPUs, we're going to look at a couple different examples. We're going to look at one for Azure and one for AWS. So the first one here is looking at Azure. This one targets GPU-based virtual machines that are currently running, and the policy filters specifically for VM sizes known to have GPUs. It checks their power state and then looks at the GPU metrics collected by the Telegraph agent. What's really exciting here is that this wasn't always possible. This was recently contributed by Stacklet to support the new GPU metrics namespace in Azure, which means that which made surfacing these metrics more straightforward. And that I just want to point out that that really shows the power and extensibility of Cloud Custodian because it's policy driven and community supported. We were able to make this contribution pretty easily, and now everyone can take advantage of it to manage GPU spend more effectively. So the next example that we're going to look at is AWS based, and this policy focuses on AWS GPU-based EC2 instances that are currently running with low GPU memory utilization. So this one filters for instance types known to have GPUs, verifies that they're in a running state, and then evaluates GPU memory utilization metrics. These metrics come from the CloudWatch agent, which collects telemetry directed from NVIDIA's NVIDIA SMI tool. And I just want to point out, which is also in the notes of the policy there, that there's a couple different prerequisites to make this work. The CloudWatch agent must be installed and configured on the instances. Also, the agent configuration must include the NVIDIA GPU section to collect GPU metrics. And then also the appropriate NVIDIA drivers need to be installed. So as long as you have all these things in place, Cloud Custodian can quickly surface underutilized GPU instances and helps teams decide whether to right size, pause, or decommission them. So the key takeaways to wrap up, the big idea today is that hidden savings aren't just in compute and storage. We need to focus on things like networks, data transfer, and GPUs because they can quietly eat away at cloud budgets if we're not paying attention. The key is visibility and automation, and Cloud Custodian policies make these costs discoverable and give us the ability to take action at scale. And because Custodian is extensible and community driven, we can adapt quickly to new needs like GPU metrics or evolving services. And so that is how we turn hidden drains into sustainable savings. Um, and that concludes my presentation. So I just want to thank everyone for joining today, and I will pass back over to